When I solve polynomial and rational inequalities, I handle things just a little bit differently than the textbook authors do in some cases, and I wanted to work through a couple of problems just to show you what I do differently, and I think it works better. It's up to you how you choose to do that. First of all, what your textbook authors refer to as boundary points, I'm going to call split points. I tend to look at them as points that split up the number line into different sections, so in my mind they're split points. We're going to start with a polynomial, and just like with what you've been shown in the other in your text and on the other videos, you want to start by sliding everything to one side of this inequality. So we're going to make that a minus x and a minus 3 less than 0, and then factor, and we're going to factor by grouping. X plus 3 is left. I factor out a negative 1 out of those two terms, and x plus 3 would be left. So then x plus 3 factors out, leaving x squared minus 1. And x squared minus 1 factors to be x plus 1 times x minus 1 less than 0. Now bringing down the less than 0 on each line is a good idea. Now the split points that we're going to be looking at come from setting each of the factors equal to 0. So my split points are negative 3, negative 1, and positive 1. I'm going to put those split points on a number line. And I'm also going to go ahead and indicate on this number line that each of those values of x makes the inequality have a value of 0. Now, I look at the inequality symbol, and that tells me that we are not going to be including any points that make the inequality equal to 0. We're only looking for things that make the inequality less than 0. So I'm going to put an open endpoint, an open circle on each of my split points to begin with. Next, pick a test point from each little section. So the test point that I would pick for values of x less than negative 3, I would probably pick negative 4. And here's what I would recommend that you do. I would look at the factored form of this inequality. I'm going to look at the factors x plus 3, x plus 1, x minus 1. And if I think about substituting in a negative 4 in there, negative 4 plus 3 is negative 1, negative 4 plus 1 is negative 3, negative 4 minus 1 is negative 5. If we multiply those three negatives together, we're going to get negative 15. What's important to me is not the 15, but the negative. So I'm going to indicate above the number line there that I have a negative section. And then I'm going to move on to the next section. I'm going to pick my favorite number in between negative 3 and negative 1. I would choose negative 2 in there. And then substitute into the factored form of that. Negative 2 plus 3 would be 1. Negative 2 plus 1 would be negative 1. Negative 2 minus 1 would be negative 3. And that's going to give me a positive answer. I don't really care what number that is. I just care that it's positive. And then I indicate that on the number line. See, I use negative 2 right there. The next split point between negative 1 and positive 1, I would choose 0 because it's easy to plug in. That's going to give me a negative product, which I indicate on the number line. And then picking a number bigger than 1, I'd probably pick 2. 2 plus 3 is 5. 2 plus 1 is 3. 2 minus 1 is 1. Gives me a positive solution there. Okay. Now, focusing in on the fact that our inequality is less than 0, that tells me that it's the negative sections that are going to be our solution. So I'm going to shade the parts that are negative. So my solution set would be the interval from negative infinity to negative 3, not including the negative 3, union negative 1 to positive 1, not including either of those endpoints. There's our answer. Same basic process if I've got a rational inequality to solve. So let's look at 2x over x plus 1 greater than or equal to 1. Now, we've got to start the same way. We need to subtract 1 from both sides. And then you've got to rewrite the 1 so it has the same denominator as the fraction. So 2x minus x would be x minus 1 over x plus 1 is what I'm going to be working with. The split points, the value of x that makes the top equal to 0 is x equals 1. The value of x that makes the denominator equal to 0 is x is negative 1. Now, we need to be very, very careful. You cannot allow the denominator to be equal to 0. So negative 1 is a split point, but I'm going to make sure it's very obvious I cannot include that split point in any of my solutions. So number line, putting the split points in there. Those are the values that give us 0. Okay. Now, looking at the inequality, this time we've got let greater than or equal to. So the value x equal 1, which would make our fraction equal to 0, that's going to be okay. So I can put, oops, not with that color. I can put a filled in circle at positive. Oh, wow, my number line is wrong. Wow, wow, wow. Okay, fix that. Negative 1 to positive 1. Okay, positive 1 can be a solution. Negative 1 cannot. Okay, and those are the values that give us 0. So, picking out test points. If I choose negative 2, let's see, working with this form, negative 2 minus 1 is negative 3. Negative 2 plus 1 is negative 1. That's going to give me positive 3. If I choose 0, negative 1 over positive 1 gives us negative 1, so that section's negative. And maybe positive 2. 2 minus 1 is 1, 2 plus 1 is 3, and that's positive. So then we look back at our inequality, what's circled here, and decide is it the positive parts or the negative parts that's our solution. And in this case, it's positive because we are greater than 0. So shading this section. And then the solution, I just read right off my number line. I would have the interval from negative infinity to negative 1, not including the negative 1, union the interval from 1 to infinity. This time we include the 1 because of the greater than or equal to on the inequality.